Hi guys, I'm back. We're going to go over the rest of chapter 5 this time. So where we left off last time was talking about now that you know what independent variables and dependent variables are, we're going to talk about why you would select a particular dependent variable and what are the issues going on when you do decide on a dependent variable. Up to this point, we talked about essentially the sensitivity of a dependent variable. One good example of that was the idea of rating scales. Sometimes you can have a 3-point rating scale, like I said with the MMPI. You are going to either agree with the statement, disagree with the statement, or say neutral. Other common rating scales that you're familiar with would be a 5-point or 7-point rating scale, or a 10-point rating scale. When you think about the colloquial use of attractiveness, a 10-point rating scale. But could you use a 14-point rating scale, which is basically what your grading system is? Basically the idea is that there's no right or wrong answer, but to make that determination in terms of how many points you want on a rating scale, either refer to the previous literature and see what's been done there, or pilot your measure out to see what gives you the sensitivity that you need for your particular experiment. All right. The last thing I also left off with was the idea of the odor identification example. So you could have a scale where you just have a right identification versus wrong identification. The example I gave for that was if you blindfolded somebody and gave them the scent of orange. If they said orange, you would say that's a right answer. If you said citrus, is that a right answer or a wrong answer? It's not as good as orange. So if you decide that beforehand, you may say, citrus is not a right answer. So you go right versus wrong. Okay. The alternative to that is to make it more sensitive to have some sort of point system. Through pilot testing, you determine what answers you would give 1 point to if it's, close enough to being the right answer. 2 points for the real answer, the specific right answer, and then 0 points if the person says, sausage instead of orange. Okay, so those are different things. You might think that right answer, wrong answer, may be very straightforward, but sometimes there are going to be nuances like that you want to take into consideration. Okay, the next thing in the notes in terms of the idea of the dependent variable and sensitivity is what's known as range effects and ceiling effects. Okay, the range effects that are involved here is that you're doing something where your measure just isn't sensitive enough because the task is either too easy or too hard. So think of a word recall test like we did with the generation effect. What if we only had 5 words? Okay, so you might find out that the group that just read the words got 4.9 words correct as the mean. The generate group may have gotten 4.8 words right, okay, in terms of the mean words recalled. Does that mean there was no difference between the groups? Well, probably the issue is that it's ceiling effects. That is, the test is so simple to try to remember 5 words that everybody's doing well. So that's the idea of ceiling effects. The other type of range effects is floor effects, that this test is so hard that nobody's getting the right answer. What if you had, wanted to see whether or not visualization helped you do math problems right? So you have the visualization group and then a control group. But what if you have, very difficult math problems, very difficult calculus problems, and you give it to a typical psych undergraduate, and you find out that, maybe the mean is 2 answers right for the control group and maybe 2 answers right as a mean for the visualization group. Does that mean that there's no difference? There's no effective visualization? No, it just means that the task was too hard and you're not getting a difference between the groups because your measurement is, you're not teasing out any sort of effect of the independent variable that you did because nobody's doing well on it. Okay, so that's basically the idea between ceiling effects and floor effects. How do you know if they occur? You just have to check the means afterwards. Again, the other thing that would help is pilot testing, see whether or not a lot of people are getting the questions right or getting too many of the questions wrong. So between pilot testing and then checking the data afterwards, that's how you determine whether it's ceiling effects or floor effects. Right. The next part is tailoring the dependent variable for your participants. Key examples of that is dealing with children. Okay, we actually talked about this in the previous chapter in terms of the idea of visual infant perception. You know, the preferential looking task and the habituation task. You can't ask an infant what they see, so you're not going to be able to use, you know, any sort of measure that we would usually use for acuity that we would have for adults. So we use these measures like habituation and preferential looking. Okay, even with children that are a little bit older, this is something you're probably familiar with, especially you had kids and you've been to a hospital. You know, when you go to a hospital and the doctor or the nurse wants to determine what the child's pain level is, you know, for adults, usually it's on a 10-point scale. For children, though, they use, you know, the smiley faces and sort of emoji looking things. So you have a frowny face for the child to say, you know, I'm feeling painful, and a big smiley face for if you don't feel pain at all. And then there's the, you know, the gradations in between. Okay, so again, you want to make sure that, you know, the participants are able to use the dependent variable that you have. So again, children, you know, as young as maybe 3 or 4, not so good with using numbers, and especially in terms of rating their pain. But the smiley face, you know, dependent variable really is used quite often, especially in hospitals. Certainly can do that as well in any sort of experiment that you want to do. Right. The other thing is the vocabulary that you're using suitable for the participants. Example of this that I, you know, gave you here was Dr. Walford and I did a study on disability simulations a while back, and one of the things that we asked people after they simulated disabilities, basically a rating scale as to how they felt by adopting either a visual disability, that is going around with, you know, goggles that, you know, made them not be able to see central vision, or putting earplugs in their ear to simulate deafness, or at least partial deafness. So not too surprisingly, we had things like dependent versus independent, and most people, you know, again in that situation felt more dependent, simulating that disability. But one of the things that we found out is that we use the word copaesthetic as one of the dependent variables that we were interested in. Turns out not everybody knew what copaesthetic was. I mean, we thought a college population would know that, but not everybody did. So, you know, I don't know if you guys know what copaesthetic is. Basically, it's feeling very satisfied or very satisfactory. Okay, or as one student mentioned a while back, feeling chill. Okay, so you know, we just didn't know that would exist. Luckily, we were right there to answer any questions as to what copaesthetic was. But remember, we talked about online tests. You know, if somebody had a question about that, they couldn't just ask us what it is. Okay, so you really want to make sure that, you know, even though you think the vocabulary is suitable for the population of interest or your participants, you know, may not be the case. All right, so that's basically the wrap on dependent variables right now. Okay, then the next thing in the chapter is the idea of control variables and / confounding. Control variables are any potential independent variable that you could use, okay, in an experiment, but you're not using that as an independent variable, but you're going to control that. You're going to make sure it's the same for, you know, each person in the experiment, whether in the control group or the experimental group. So for this particular example, I'm just going to go with the, you know, the simplest case control group and one level of the independent variable. Okay, so for example, if it's a teaching technique, all right, you have one group of students being taught in one particular way. Let's say it's a flipped classroom, and the other classroom is taught with traditional lecture. Okay, so what would be the control variables? Well, the time of day. You would want to make sure that, you know, the time of day was the same for each of those groups. Okay, you wouldn't want to have somebody, you know, in the flipped classroom as an 8 o'clock a.m. class and then compare that to traditional lecture at 2:20. Okay, so again, the time of day would certainly be different and make an effect on the dependent variable there, the learning outcomes. Okay, the room, the lighting, the heat in the room, any sort of ambient situation. If you control those things, then it's the same for each of the two groups. Okay, and therefore, again, the whole basis behind experimentation is that if the two groups are only different with the variable that you're manipulating, then if there is a change in the dependent variable, it's due to that change that you made, the one that you manipulated, and not to any other extraneous factor. Okay, so when that doesn't happen, we call that a confounding variable. Okay, so the classic example that I left you in with the on the PowerPoint slides is the effect of music on word recall, let's say. Okay, and this is typically something that students are interested in and have proposed as being their experiment. So let's say they choose as their independent variable rap music and classical music as their two levels of the independent variable. Okay, so what's the main difference between classical and rap? Well, one of the things that you probably would think about is that rap music typically is very much involved with lyrics, okay, and classical music not so much. Okay, most of the classical music that is all instrumental, and the rap music that heavily involved with lyrics. Okay, so if there is a difference at the end between word recall between the two groups, how do you know it's just not words being said in the rap versus no words in the classical music? So it's not the music itself, it's just the presence of words in the rap music versus the classical condition. Okay, so if you don't control for the lyrics, the words there, then that's a confounding variable. There's a whole bunch of great examples at the end of chapter 5, and we can step through a couple of those next class. Okay, all right, so the other thing that is covered in this chapter is the different types of experiments. Okay, so typically, again, we've been talking about having, in the simplest case, one independent variable and one dependent variable. Okay, but you can have a multiple control group situation. So you could have, again, in terms of a drug study, let's say, the subjects do not get any of the medication. Okay, another group gets the placebo group, and then there's the true level of the independent variable that's given. Okay, so you now have two control groups, a true control group and a placebo control group, and then the levels of your independent variable. Okay, actually, a lot of the examples in your book this go around, okay, are examples of having more than one independent variable, and that's another type of study that you can have. Okay, the example in the text is the even though there's subject variables, one of the examples in the book is having males versus females and gender and culture on the ability to do the rod and frame test. Okay, so again, you treat those as two independent variables, even though they're participant variable characteristic variables. But again, that would be an example of two independent variables, or two quasi-independent variables as they're also called, and then one dependent variable, how well they do on this rod and frame task. Okay, okay, so the Bobo doll study, there was more than one level of the independent variable in that study that they mentioned. Okay, so you had the live model versus the performed aggression. They had the live model not performing aggression on the Bobo doll, and they had a cartoon version of that, and then they have a video version of that. So they had 4 different types of levels of that independent variable, the amount of violence that the model did on the Bobo doll. Okay, and spoiler alert, your article on helping behavior, that was 2 independent variables. Okay, so we can talk about that next class also. Okay, so you can have more than one independent variable. You can also have experiments with more than one dependent variable. For example, this happens a lot with any sort of physiological measures. if you're interested in anxiety, whether anxiety was reduced by your treatment, well, how do you want to measure anxiety? You can measure heart rate. That would be one. You could also measure blood pressure. You could do that. And you could also have a paper and pencil test of anxiety. There's a number of different anxiety questionnaires that exist. So to get a full idea of whether anxiety is happening or not with a person, you can use all three of these dependent variables to see whether or not they converge to show that anxiety was being decreased by your treatment. Okay. All right. So again, major ideas then are, up to this point, the sensitivity of the dependent variable. Okay. The the different types of experiments that you can have, and also the importance of making sure that confounding variables do not exist in your study. Okay. All right. The one last thing that they mention in the chapter also is the idea of validity of the experiment. We talked about that briefly last chapter, because we were talking about the validity of a measure. Now we're talking again about the validity of this study. Is the study methodologically sound? Is it confound free? So what you think is happening is actually happening. Okay, so there's other threats to internal validity besides just confounds, especially when you have studies that exist over time. So if you have a pre-test versus post-test situation, like is mentioned in the book, okay, and if you didn't have any sort of control condition, what are the things that could happen between the pre-test and the post-test? Well, two of those things are called history and maturation. Some life event could occur. Who knows what that could be, right? Okay, something happens in between when the pre-test happens and the post-test happens that is totally not related to your treatment. Okay, or it could be just maturation, that the participants change over time, especially if we're talking about this in terms of, like the book says, in terms of freshmen or first-year students, from month 1 to month 3. There's a whole lot of adaptation that occurs in that time frame. So the participants may just mature over that time. Okay. There's also what's known as regression to the mean. You test somebody once, test somebody the second time, they're going to be more likely, so any sort of extreme scores are actually going to get closer to the mean. And then the last thing is any sort of testing and instrumentation issues. Once you get the test once, you're just more sensitized to it the second time, and that has nothing to do with any sort of treatment that you impose, okay, or manipulate. Okay. The other participant problems, subject selection. Are you actually randomizing people into groups? That's key. The Brady experiment mentioned in the book, as famous as it was, did not actually randomize the monkeys into the two conditions appropriately. Okay, so that, again, even, established researchers can get this wrong. Okay, so what's key is that you do make sure that everybody is randomly assigned into groups. Okay, and the second problem with, any sort of post-test, pre-test type situation is attrition, that you just may have subjects drop out from time 1 to time 2. Okay, all right, so the other thing that is in the PowerPoints, but I realized afterwards that the idea of participant types is actually covered in Chapter 6. So even though it's in the PowerPoints right now, I'm going to hold off on discussing that until Chapter 6. Okay, but in the interim, like I said, maybe you want to take a look at the application exercises at the end of Chapter 5. Okay, so there's scenarios where you have to identify the independent and dependent variables. Also, exercises where you have to spot what the confound is. So hopefully those are things that, take a look at those, especially spot the confound. Number 4 is actually very similar to what we're doing with the helping behavior article. So you may want to take a look at that, and we can discuss that next time. Okay. So, again, look through application exercises 5.1, identifying variable, and 5.2, spotting the confounds. All right, so we're almost at our limit for today. So take care. We'll talk to you soon, and stay safe and sane, you guys.